In the last video we talked about the construction of the electric motor. So in this video we will talk about the working of the electric motor. So when we switch on the current, the electric current moves in this direction. So electric currents goes on moving in this direction, and then it first goes, or it first passes through a from the arm, from the length AB, then it travels to BC, then CD, and then it comes to Y, and then it completes the rotation. So the position of the current when the armature, the AB side of the armature is to the left, then the current, the position, or the motion of the current, yes, the motion or the movement of the current, or the direction of the current is A to B to C and to D. So this is the current. Now as the current is moving here, so this is the current moving in these directions, this directions. So the current is moving, and the north pole has got some magnetic field, and it's a magnet. So let's draw the magnetic fields. So it's if these are the magnetic fields, then the length AB is perpendicular to the magnetic field of the north pole of this magnet. So if these are my gray color magnetic fields, then it is perpendicular here, so maximum amount of force is applied. Now you know that a force is applied on a current carrying conductor when it comes in contact with the magnetic field of a magnet. So hence the force is applied according to Fleming's left hand rule. The force is applied on AB, and hence AB is pushed upwards. So it is pushed upwards. And similar case happens with CD, but as the current is in the opposite direction, the branch CD is pushed down. So it's pushed down due to the change, due to the magnetic field and the current it is possessing. So it is pushed upwards, and the other is pushed down. Now when it completes the rotation, the the arm CD comes in contact with the the carbon brush X, and the arm AB comes in contact with Y. So they have changed the position. So now if I label this as, if this will be my, then this will be D after the rotation, after one rotation actually, then this will be C, this will be my point B, and this is my E. So they have changed the positions. Now the current will move from, now the direction of the current will be the same, but the points through which it's passing will be like D, C, B, A, which is exactly opposite to the first. So this is our first, these are the first points through which the current was moving, and this is a second point, these are my second points, or the, yes, second points the current is moving, second points where the current is moving. So again the force will be force will be applied on branch DC, and it will be pushed upwards, and AB will be pushed downwards, and hence it will complete it will complete another rotation, and this will keep on happening and happening till we stop this electric current. So in this way, when we switch on the current, we see that the motor starts moving. Now actually this is closed, all these components, not the wires, all these components, see this components. So these are my components. So all these components are enclosed in a cylindrical tube. So this is the cylindrical tube is just like that, and show you in a second. So the cylindrical tube is just like that, and then the magnets are placed. Oops. So the magnets, I have got red color magnets. So if these are the magnets placed here, So this is my N North Pole, this is my South Pole. Then the armature is placed like this, like this, like this, like this, like this, and like this. And then the here it comes the axle. So here that the cylindrical axle, then all the carbon brushes and rest of that come here, and they are connected. A small wire can be connected here to this, and the two terminals of the wire are let out of this cylindrical tube. And what we do, and yes, and there is the armature we get is not like rectangle. You will see in a motor that we get a rod that moves. So this armature is connected to a rod like structure that has also got an axle so that it can move easily, and that rod like structure is let out of this cylindrical tube. So this is my rod like structure, it's connected to the armature. So these are my, if this is my N, this is my South Pole. And what we do, and it's all enclosed, remember it's all enclosed in a cylindrical tube and metallic tube mostly. And then, and what we, when we start the motor, we actually connect these two ends to the terminals of the battery. So if this is my battery, then we connect it through the connecting wires. Connect my one end, and this is my another end. So if this is my positive, my negative. So we connect, and then it starts rotating. Yes, it starts rotating. So should by showing a circle, so it starts rotating like this. Now now if I want to change the direction of its rotation, I mean if it's rotating clockwise, if I want to make it anti-clockwise, then what should I do? Simply I will change the current. That is, I will put the positive terminal over here and the negative terminal over there. So I will switch the terminals of the cell through which the current will move in exactly opposite. That is, the current will move in this direction. Now if I switch, then all the things will be vice versa. That is, this arm will be pushed upwards, this will go down, and the motor will start rotating this way, which was actually rotating that way. So I hope you are now clear with how the electric motor works, which we use in most of the instruments in our daily life.